Okay, the law of cosines or the cosine law, right? It's referred to either way. Your textbook actually calls it the law of cosines, and that's often what it's called. So we know that we can use the sine law to solve non-right angled triangles. Okay, there's no worksheet just in case you're looking for one. So you actually might want to haul out a piece of blank paper if you want to take any notes, and if you don't, then you don't have to. So if we want to solve a non-right angled triangle, we develop the sine law, which says that the ratio of the measure of little a over the sine of angle a is equal to the ratio of the length of side b to the sine of angle b, and so on. Now, in order to do that, we need what we call a known pair. You need to know an angle and the side opposite that angle. So, what happens if you don't know that? Then we need another method, right? So, here's the law of cosines. We start with triangle ABC, with sides little a, little b, little c. And it's sort of the same. Grant, do you want to teach this lesson?
No.
Then what are you going to do? So, start with the same idea that we did with the sine law, which is to drop an altitude, which we will call h. And of course, it's perpendicular to line AB. Right, sorry, that little c is this length, right? So just write the little c down there, and we'll call this D to make up that angle there. And we're going to call this side here x, which makes this how big? How big is that? Yeah, let's call it c minus x, little c. Okay, because little c is this length here, right? And what we're going to do is we're going to get an expression for the cosine of angle A. So what's an expression for the cosine of angle A? Or actually, well, before we do that, actually, we could say in this right triangle here, there's a relationship between B, H, and X. What is that relationship?
X squared plus H squared.
Yeah, so B squared is X squared plus H squared, right? Just the Pythagorean theorem. And what do we know about the cosine of angle A? What's that equal to? X over B, right? Which means that we can solve that and write that X is equal to B cos A. All right? And we're going to want to do some similar stuff with this other triangle. So what relationship is there between H and C minus X and A? A squared is equal to C minus X quantity squared plus H squared. And so, taking that, we can say, well, what are we going to do with that? We're going to expand that out a little bit, right? So we're going to write A squared is equal to C squared minus 2CX plus X squared plus H squared, right? Now, what's X squared plus H squared? B squared. So we can go down here, we can put in a B. Plus B squared. So it'd be nice to get rid of that X, right? Because we want an X in there, and we'd have an expression that involves A, B, and C. So what can we do to get rid of the X? we can put b cosine a, right? All right, so a squared is equal to c squared minus 2. And what are we going to write? We're going to write b to c b cos a.
Capital A.
Oh, right, sorry. Capital A. It's the cosine of an angle. Plus that. So, let's rearrange this a little bit. And so the final formula we're going to write is a squared is equal to b squared plus c squared minus 2, and let's go alphabetical order, bc cos a. And that's the cosine law. So it relates to 3 sides of the triangle and 1 angle. Okay? So it's got all 3 sides, a, b, c. Actually kind of looks a little bit like the Pythagorean theorem with something hung off the end. So if angle A were 90 degrees, what's the cosine of 90 degrees?
1.
Try again. What's the cosine of 90 degrees?
Error. I divide.
No.
0.
What's the cosine of 90 degrees? What's your mark on the test going to be if you don't know the cosine of 90 degrees?
0.
Right. Okay. So if the cosine of 90 degrees is 0, that's going to take this term out, and what are we left with?
A squared plus
Huh?
B squared.
Yeah. Pythagorean theorem, right? So
Yeah.
if angle A were a right angle, then we would just have a squared equals b squared plus c squared, right? Where a, little a, would be the side opposite the right angle, aka the hypotenuse, right? So, you know, you could always use the cosine law and never have to worry about using Pythagorean theorem, but I mean, I wouldn't. It's just more efficient to use, you know, if you know that it's a right angle triangle. So similarly, of course, we could drop altitudes here and get alternate forms of this, right? So extending yon page, we've got a squared is equal to b squared plus c squared minus 2bc cos a. B squared will equal a squared plus c squared minus 2, what do you think? AC cos b. And what's c squared equal to?
B squared plus C squared minus 2AB.
Yeah. Okay. So you're going to get one of those on your formula sheet. I'm going to go look at which. If your sides are p, q, and r, then it's p squared equals q squared plus r squared minus 2, right? Then these guys go here, and the angle associated with that goes there, right? So this allows you to find a side if you know, well, let's just draw it an ABC again, right? How did I orient that? A, B, C, little a, little b, little c. So if we want to find little a, that's the thing we want to find. We have to know b and c and angle a. And you notice, this is not a cosine law problem, right? Because if I know angle A, I don't know the side opposite it, right? And I need that to do sine law. I have little c, but I don't have angle c. And I need one, and I have b, but I don't have angle b, right? And I have 2 unknown angles. There's no way to know, right? If I know one angle, that doesn't give me the other 2. So this gives me a way to solve for if I know 2 sides and the enclosed angle, the included angle, right? Which is a side angle side proposition, right? When you're familiar with the triangle congruency rules, that side angle side, there's only one possible triangle that has these measurements, right? If I give you a side, the angle contained in another side, that's it. Everybody draws the same triangle. Similarly, we can rearrange the equation to solve for an angle. So let's take this. Let's go to a new page. So starting with this, a squared we can solve that for the cosine of A. So what are we going to do? Well, we're going to get stuff by itself, right? So we're going to go a squared minus b squared, got to subtract b squared, minus c squared is equal to negative 2bc cos A. So I need to divide both sides by negative 2bc. And while I do that, I'm going to flip the sides at the same time, right? So I'm going to write cos of a is equal to this, a squared minus b squared minus c squared over negative 2bc. Now, we don't like to leave a negative sitting in the denominator, right? So we can multiply top and bottom by negative 1. That will change all of the signs, so the b squared and c squared both become positive, minus a squared over 2bc. And that is the other form of the cosine law that you will get, right? To save you from having to solve that. You know, it's not that you can't do this, but it's sort of like why. Okay, so the cos of a is equal to b squared plus c squared minus a squared over 2bc. And if it's triangle PQR, right, I mean, if that's a P, then that's a P, and these guys are the Q's and the R's, right? So this works if you know all three sides, right? I got to know A, B, and C. And if I do, then I can find an angle. Once I found the angle, I'll then have a known pair, and I can use the sine law from that point on, right? Because cosine law is a little, you know, a little unwieldy in a sense, right? I mean, there's a lot of stuff in there. Sine law, it's like, you know, 10 times sine 20 over sine 15. That's pretty easy to type into a calculator, right? Boom, done. Whereas this, you know, not only this, but then it's got this, and it's got that division there. And so we need to practice this. So get out your calculator, because you need to practice these, right? I want to make sure that you, when you're doing the examples, right, that you know how to enter it in your calculator to solve it. Okay, so let's do some examples. Where we will require the sine law, cosine law rather. All right, here's one. First example. That will be nice. A, B, C. Well, this, you know, saying get out your calculators was actually saying, I said get out your calculators, you heard turn on music and start talking now. I don't believe that's what I said, but you know, who knows, it's late in the year. It's getting short, we're almost done, right? I mean, what's left in this course, right? What's left? Well, so cosine law, ambiguous case of the sine law tomorrow. And a couple of days working on mixed problems, and you come back, you write a test, and then you write your final exam. So, you know, really, there's like one class of new stuff left. That's tomorrow. The ambiguous case of the sine law. I don't know why we didn't do that today, but we didn't. So I just follow orders. In the order of the thing, I follow the order of the paper. Get it? Funny. Yeah. Okay, so we want to find
I don't see the
little a. Actually, you know what? Let's just solve this triangle. Solve this triangle. And by this, I mean that triangle. Solve this triangle. Solving means to find what? Or determine, really. Determine all the angles, all the sides. You got to know all the angles, right? That's just a saying in life. You should know all the angles. This is where it comes from. I have no idea. Probably not where it comes from. All right, so presented with a problem like this, let's pretend that now we're doing sort of mixed problems, right, the other day. So you look at this, you say, all right, I want to use sine law. No. Well, I want to use SOHCAHTOA, right, because it's not a right angle triangle. Okay, I'm not going to do that. Well, you know, I could drop an altitude. Yeah, then I don't know how big stuff is, and that's just a lot of work, but possible, I suppose. Sine law? Nope, don't have a known pair. Therefore, cosine law. So let's label. Okay, write out the formula you're going to use. A squared is b squared plus c squared minus 2bc cos of angle A. Okay, so here's how I do this when I'm doing it on my calculator. Right now, there's a couple things to keep in mind. If you just plug into here, you know, the b's and the c's, and you square them and you add them and you subtract them and all that good stuff, you'll get a number which is really big. And the look back part of problem solving, right? Remember, 4 steps problem solving: understand, plan, do, and look back. So understand, well, we got to solve the triangle. Okay, plan. I'm going to use the cosine law, and then we'll use the sine law to get another angle, and then we'll use 180 minus to get the third angle, and we'll be done. Okay, but cosine law first to get the side, then I have my known pair, etc. If this is 7 and this is 8, what is the absolute largest that A could be? Now, what's the absolute largest? Like, let's say I opened up the 7 and the 8 flat.
7 plus
15, right? So if you get a number bigger than 15, you know for sure that it's wrong, right? Because you can't even make a triangle like that. And so the thing is, if you just plug into here and you end up with a squared, it's probably going to be larger than 15. And at that point, you should know, no, okay, wait, I've got to take the square root of it, right? It's the same deal like when we found the sine of angle A. If you didn't do an inverse sine and you just said, sine of A, oh, that's 0.5 degrees. Not likely, right? We don't have too many triangles we play with where you have a half a degree in the angle, right? Because it'd be a pretty flat triangle. So what I like to do is this. I want to do A, it's the square root of, 8 squared plus 7 squared minus 2 times 8 times 7 cos 48 degrees. So on my calculator, I'm going to type in second function square root and then the rest of that. Make sure it's in degrees, though.
but it looks different. I faintly remember 2 degrees. Yeah, I know. It's the same calculator. Remember 2 degrees. Oh, that's because.
Okay, what'd you get? A equal, let's go to 1 decimal place. So what is it? But we're going to keep that number in our calculator. 13.6.
6.2, yeah.
What?
13.6. Wait, what were you trying to find?
What?
13.6.
What's A?
13.6.
Oh my god. Look, I swear one of you left this calculator here. If you don't want to claim it, I'll keep it, but that's fine. It's got a sticker on the back.
Put it all together.
And somebody wrote something on the sticker. It has to be one of you, right? One of you didn't leave this? Like, seriously? What's A? Alright, anybody who didn't get 6.2, can you now get 6.2? And why didn't you get 6.2? 6.16, yeah, 6.2. 6.2. Oh.
Chickens per meter squared. We talked about this.
6.2 centimeters. Good. I'm going to put this video up for the other class. They're going to think, who did you record this for? Like, what a bunch of idiots. I mean, seriously.
Chickens per meter squared are delicious.
Okay, so 6.2 centimeters. Now, what we want to do, because we're going to use that number with the sine law to calculate angle B or C. Any preferences? What does that tell you? Where does 48 rank in the pantheon of angles in this triangle? Biggest, smallest, in-betweenest?
Unknownest?
No, I know. Is 48 degrees the largest angle in this triangle, the smallest angle in this triangle, or the in-betweenest angle in this triangle? Too bad you guys don't understand math. It's the smallest. Why is it the smallest? It's the smallest side. The smallest side is across this side. 6.2, if I haven't lost my mind, is smaller than both 8 and 7. So that fits 2 things, right? Because if we didn't do the square root here, we would have a 36 or 37 or something and say, whoa, wait, that's got to be a little bit too big. And then it's a 6.2, it's opposite the smallest angle. So that means this is big. They aren't hugely bigger, right? I mean, nothing is like 95 degrees, I don't think. But let's find out. Okay, so leaving the 6.169065739 sitting in our calculator, right? We're now going to work out, let's do B, right? Just because alphabetically it's sort of. So B over sine B, no, we know B. We want to get angle B. Sine B over B is equal to sine A over A. Sine B is equal to B sine A over little a. I'm just going to kick up here. B is equal to the inverse sine of, and now I'm going to fill in my numbers. So B was 8 times the sine of an angle A was given to us as 48 degrees over little a. So that's the 6.16, right? So I'm just going to use second function answer to get that number in. So I'm not going to rely on any of you all for this. So sine inverse 8 sine 48 close bracket divided by second function answer. And I get 74.5 degrees.
That looks like CD.
Okay, and now if I want to calculate angle C, then I will use 180 minus 48 minus 57.5. Is that it? We done? We got everything? Little b, sine A, little a. Little b, sine of angle A, little a. All right, so I've got angle A, angle B, angle C, side A, side B, side C. We're done. It's all solved. Okay. And generally speaking, you should only ever have to use the cosine law once. Okay, because after that you can use the sine law. All right, what's next? Next. In triangle. PQR. And ooh, that's a dirty one. Sure, let's do this. Not only will this use cosine law and other things, tricky. So, what should we do first?
Draw it out.
Yeah, draw it out, right? Always draw it out. Okay, so I'm gonna draw a flat line there. What would you like? So let's make this, what, 11, 9, 10?
Triangle. 5 and 6.
Make this the 11 side.
16.
10, right? Doesn't really matter. Okay? But now when I'm going to work out the area, then I'm going to use the 11 as the base. We're going to have to find the height here. In order to do that, we're going to need an angle inside the triangle. And then we can use a little right angle triangle trig to get the height. And then we'll use a 1/2 base height to get the area, right? So, we need an angle. First, I guess we should label this, right? This will be angle P because it's opposite the 11, and this will be Q because it's opposite the 9, and this will be R because it's opposite the 10. So let's triangle PQR. Which angle would you like? Q. Sure, why not, right? I mean, we could do P, but then we'd have to draw our altitude somewhere else, and that's just kind of awkward, so Q works for me. Okay, so we want angle Q. So the cosine of angle Q is, its formula, P squared plus R squared
Minus Q squared.
over,
2.
there you go. Okay, so it's just like ABCs, only with PQRs. Okay, so the cosine of angle Q is equal to P squared plus R squared minus Q squared over 2PR. And we know P and Q and R, so we can fill that in. Now me, I like to go straight to the angle. So I'm going to write Q is the inverse cos of P squared, it was P, Q, R. These not look here instead of up there, but okay, so what do we got? 11 squared plus 10 squared minus 9 squared over 2 times 11 times 10. Okay, I'm going to pause this because it's going to take you like 15 minutes to agree on it. Okay, so in your calculator, to get Q, it's going to be cos inverse, and it's going to give you a parenthesis, right? And you're going to then put a parenthesis and go 11 squared plus 10 squared minus 9 squared and put a parenthesis. Because this division bar means work out the top, work out the bottom, then do the divide. So you go divided by, and then,
2 times. Why do you make a star?
because that's what your calculator shows when it does. Have you not looked in your calculator?
No. Grant doesn't
Okay.
use calculator.
So that's what you want to do, right? Is you need to work out the top, work out the bottom, do the divide, then have it do the cos inverse cos of that, right? And it should be, what do we say? 50.478. Okay, so, but we got to do some more calculations. We're going to use the exact value that's sitting in our calculator, right? So actually, really, we weren't asked to find angle Q, were we? So 0.478, right? So I'm just showing, hey, we picked up the full number, we're using the full number. Okay, so now what we want to do, we're going to drop down this, we'll call that H for height. This is 50 degrees. We have the side opposite and the hypotenuse in this little triangle here. So we can say that sine, so sine of Q is equal to H over 10. So H is equal to 10 times sine Q, which is 10 times sine 50.478. Okay, so in your calculator, you're just going to go 10 times sine, second function answer, and hit enter. And what do we get? 7.7? 7.713, right? Because we're not done yet. That's not really the answer we want. The answer we want is the area. So area is 1/2 base height. It's 1/2. The base is 11. The height is 7.7. And the area rounded to the nearest tenth is, so what do you got, times 11? What do you got? 42.4. No. Now we're rounding to the tenth because we're done. 42.4.
Meters.
Yeah, no chickens, just meters squared. 42.4 square meters, right? So if you were laying this triangle out, as a, landscaping or something like that, and you needed to order sod or whatever, or you wanted to mulch it or something, and you needed to know, well, what area do I have? Then that gives you your area. And if you then wanted to dig down a meter or something to put new soil in there, then you'd know you needed 42.4 cubic meters of stuff, to fill that in. Okay. So that's where this comes in, right? So we're solving, we solve for an area, but in order to do that, first we needed an angle within the triangle. The cosine law works to solve for an unknown side if you know two sides and the included angle, or an unknown angle if you know all three sides. Sine law, you need a known pair, right? You need an angle and the side opposite that angle. So today it's cosine law problems, obviously, right? Tomorrow it'll be mixed problems. So sine law, cosine law here. There's still right triangle trig in here. You know, Pythagorean theorem might come in. All of that good stuff. All right, so way you go, cosine law. That should be pretty much everything you need. Let's say